Someone is praying for you. Someone is praying for you. So when it seems you're all alone and your heart will break in two.
Hello, welcome to our lessons on ordinary differential equations. In this lesson, we are going to start by looking at the higher order linear differential equations. In this video, we will start by looking at what equations are classified as higher order differential equations. We say that higher order differential equation, an equation involving the independent variable x and an unknown function y with its first, second, and third, and so on derivatives. So, an nth order differential equation is of the form an of x y to the m derivative plus an minus 1 of x y to the n minus 1 derivative up to a2 x y double prime plus a1 of x y prime plus a naught y equals f of x, where a naught up to an are all continuous functions of x within the given interval. So a third and the second order differential equations respectively are of the form a3 of x y double prime plus a2 of x y prime plus a1 of x y prime plus a naught y equals f of x, and then we have a2 of x y double prime plus a1 of x y prime plus a naught of y equals f of x being the second order, where the a naught a1 all functions and continuous function within a certain interval I, and a3 of x is not equal to 0 for this, because if a3 of x is equal to 0, the whole thing here will become 0, and this equation ceases to be a third order. And a2 of x can also not be 0, because if it does, all of them also tend to 0, and the equation ceases to be a second order. So then none of them can be 0. So if you consider the second order PD of this form, because a2 of x is not equal to 0, we can divide each of them by a2 of x. So we divided this one by a2 of x, divide this one by that, divide by this one by that. And now if we let a1 of x over a2 of x becomes p of x, a naught of x over a2 of x equals q of x, and f of x over a2 of x equals f of x, then we can write the second order differential equation as y double prime plus p of x y prime plus q of x y equal to f of x. And this, we call it the standard form of the second order ordinary differential equation. Similarly to the third order, if we have the third order, we divide through by a3 of x, since a3 of x is not equal to 0. We are going to obtain this, and by letting p to be equal to dot, q to be equal to dot, r to be equal to dot, and g to be equal to dot, we can write the third order differential equation in standard form as this one. Examples of second order are this. It's a second order. Third order, this is a third order differential equation. Fourth order, this is a fourth order differential equation. It's a fourth order because the higher derivative 4, third order because it's 3, second order because the higher derivative is order 2. So if you consider an n order differential equation of this form, we have two main types of equation they can deal with, whether the equation homogeneous or non-homogeneous. We are saying that if the forcing term here, f of x here, is 0, then this whole equation becomes homogeneous. That's we are going to get an of x y to the m derivative plus a2 of x y prime prime plus a1 of x y prime plus a naught of x y equal to 0. Then this equation is called homogeneous. Otherwise, it is non-homogeneous. So let's look at a few examples of homogeneous and non-homogeneous equations. So here we have the forcing term to be 0, so the equation homogeneous, the same as this, the same as that. But if you come here, you realize that the forcing term f of x is not equal to 0, so this is non-homogeneous or inhomogeneous. So the same thing, this is the forcing term, and this is the force. So far the forcing terms are not 0, this equation is called non-homogeneous equation. Thank you for watching. We'll meet again.